Assalamualaikum everyone.
Waalaikumsalam.
How are you all?
Alhamdulillah.
So today the topic we are starting today, that is about the resistance. Okay, before starting this topic, I need to take some prior knowledge from all of you. First tell me what is the meaning of electric current? What is current? What is the meaning of current?
It flows electricity.
The flow
Electron.
of electron, it is called the electric current. Very good. The electric current is the flow of electron, it is called the electric current. Okay. Now tell me, what is the meaning of this word resistance? Yes, Reza.
Resistance means the control of the flow of the current or to stop something.
Very good. The resistance, the simple meaning of the resistance, that is the stop the current flow or to resist the flow of the current, that is the meaning of resistance. Okay. Now we come to the next thing, that is we have discussed about the potential difference, right, in the last unit. So now tell me what is the meaning of the potential difference? What is the normal word which we are using instead of potential difference in our daily life? What is that word?
Voltage.
What is that word?
Voltage.
Voltage. Okay, that is the word, it is voltage. And the potential difference, it is the scientific name of the voltage. Okay, now tell me what is the unit of voltage?
Volts.
Okay, now we will continue the topic of resistance, but before that you should know what is the objective of today's class. The first thing that we have to discuss is what is the resistance and how it will work, and the second thing what we have to discuss, that is about the factors which affect the resistance. Now to continue the topic, first I need to show you one video here. After that video I will discuss the topic with you all.
Do you remember what resistance is in an electric circuit? It is something that controls the flow of current. If it's more, then the current reading will be lower, and if it's less, then the current reading will be higher. It's inversely proportional to the current.
Okay, now tell me what is the meaning of this inversely proportional with the current? Anyone of you tell me what is the meaning of inversely proportional? Current is inversely proportional to the resistance. What does it mean? One value is going to be high and the other value is going to be decrease. Okay, it will be low. So this is the meaning of the inversely proportional. So you can see that when we talk about the resistance is inversely proportional to the current. When the resistance is increasing, so the flow of current will be decreases, and if the flow of current is increases, so the resistance will be decreases. Okay, now
Let's talk a bit more about resistance. What are the factors on which a resistance of a conductor depends? When can we say that the resistance of a conductor is more or less than that of another? Let's do a small activity to understand this. Take a small electric circuit like this one, which has a plug key, a power source, and an ammeter. In the first case, connect a nitro wire between these 2 points.
okay, the first thing, can you tell me what is the function of this ammeter in the circuit? What is the use of this ammeter? To measure the current. Very good. To measure the flow of current, we are using the ammeter over here. So now this is the experiment. In this experiment, they are using a nichrome wire, it's the copper wire, and they have shown see the current, how much the current is flowing, and we measured into the ammeter.
Let the length of this nitro wire be a lowercase l. Now plug the key and measure the reading in the ammeter. Now let's try playing with the factors a bit. In the second case, we double the length of the nitro wire, but keep the thickness same. We just double the length. When you measure the reading, you will notice that the current is half of the current measured originally.
Okay, now you can see that in the first case they are taking the length of the wire, but in the second case, what they will do, they increases the length of the wire. Once they increase the length of the wire, so you can see there is a effect of the current is also there. What is happening here? The current is going to be decreased. Why is happening? What is the reason behind it?
Because the length of the wire is bigger, increased,
So the resistance will be
it will be less.
It will be more. The resistance will be more, so the current will be less, right? Yes, that's right. Now,
When the length was doubled, the current halved. In the third case, we replace the wire with a thicker nichrome wire with length L. Understand this case well. We're just increasing the thickness of the wire without changing the original length L. Now, if you're increasing the thickness of the wire, it simply means we're increasing cross-sectional area. Let's call it A. Now, when you measure the current, you will notice that it's more than the original current I1.
Okay. Now tell me what is increasing into the third case. What is happening? What is the change over here?
The thickness is
When the thickness of the wire is increasing.
Yes.
So when the thickness of the wire is increasing, so it means we increasing the area of the wire. When we increase the area of the wire, so what is the result over here of the current? The current is going to be increased because we see here in the factor when we increase any area of the wire, so here the flow of the current is also increased. You can see here I2 is greater than the I1. Okay.
The results we're getting are pretty interesting. Let's try out one last case. We use a copper wire instead of a nichrome wire. The length and cross-section area A will be the same as the original wire.
Okay. Now in the fourth case, you can see here they changed the wire here. They are using the copper wire instead of the nichrome wire. Okay. So now tell me what is the difference here? What will be the result? What do you think? What will be the result over here in the current?
It will be the result will be increased.
Yes. What?
The result will be increased
Because the
because of
conductor of electricity.
Very good. Excellent. So this copper wire, it is the good conductor of electricity as compared to the nichrome. So here you can see the result. As you were saying, the current is decreasing. Now we will check what is the result over here.
But the material has changed entirely. When you measure the current, you will notice that it's more than I1. Now that
So your answer is correct. The current is increasing. Thus, Alice, yes, the answer is correct here. When we change the material, when we change the good conductor instead of that nichrome, so it means even the current is more. Why the current is more? It is the good conductor of electricity, and the resistance of this copper wire is more or less.
Yes.
The resistance will be less. That's why the more current will flow from the wire. Understand, Umar? Are you getting? Okay.
let's understand the results case by case. We see that as the length of the wire increases, the current reduces by the same factor. It implies that the current is inversely proportional to the length of the wire. And by Ohm's law, we know that the current is inversely proportional to the resistance of the conductor. So these two together will imply that the resistance R is directly proportional to the length of the wire. More the length of the wire, more will be the resistance. Note that here we assume everything else will be constant. It will be the same wire and it will have the same cross-sectional area, and other factors like temperature will also be constant.
Okay, now you can see here, after they performing this experiment, what is the result they are getting? The first thing they are getting that the current, the I, is inversely proportional to the length. So as we see in the different cases here, cases 1, case 1 and case 2, we can see that we increase the length of the wire. When the length of the wire is increasing, so it means the resistance is also increasing. When the resistance is getting more, so it means the current flow will be less. So that's why we are saying the current is inversely proportional to the length. So why the resistance current is inversely proportional to the length? Because the length is increasing, so the current will be decreasing. So there is more resistance will be there. That's why. Now the second thing, the length of the wire. This one. The resistance is directly proportional to the thickness of the length of the wire. Okay, when the thickness is more, so the resistance will be the thickness will be more, so resistance will be less. Okay, so the current will flow more. Okay, so these are the two factors here: the thickness or the cross section area of the wire, that is the one factor, and the second one, that is the length of the wire. Okay, now I wanted to summarize the topic. Okay, what we have discussed today. That is about the resistance. So now tell me, what is the meaning of resistance? Any one of you?
To control the flow of electricity.
To control the flow of electric current. Very good. Okay. Now tell me, what are the factors of the resistance? Any one of you? From the boys, anyone? What are the factors? of the resistance.
Length,
cross-sectional area,
material temperature, then
Yes.
material.
So these are the things, these are the factors which affect on the resistance. Okay. So now it is all about this today's class. Thank you so much, Jazakallah.